So in this question here, we need to calculate the mass of block Q, which is given as m kilograms. Now what's happening is here, block Q is falling to the ground and it's dragging block P along with it. And the string which is connected to it has got tension, which will be pointing in the direction of the pulley. So tension in that direction and in that direction. This mass here is 0.3 kilograms, and all we're given is this angle here is alpha, and tangent of alpha is 3/4. Now there will be friction along the plane, as on this incline here, that's given as 1/2. That's our coefficient of friction. Now acceleration is also given as 1.4 meters per second squared. So as this is falling, it's falling at the rate of 1.4 meters per second squared, as will be block P going up the plane. And gravitational constant is given as 9.81. So we need to calculate the mass of block Q. So for that, we're going to be using Newton's law of motion, force equals mass times acceleration. As this thing is moving, it's not in an equilibrium state or anything at the moment. So we need to resolve the forces at both points, first of all, before we get anywhere. So let's have a look at what's going on at Q. So at Q, we've got the mass of the block on the way down, which is in the correct direction. So that's going to be m times g. That's mass times the gravitational constant. And going against it will be the tension in the rope, as the tension is pointing in the other direction. And we set that, as that's our forces, we set that to mass times acceleration. Well, we've got mass is m and acceleration is 1.4. So that equals 1.4 m. So that's what's happening at Q. Now when we get to P, things are a little bit more complicated. So let's have a look at what's going on at P. So I'm going to take this little part of the diagram out and bring it over here. So that's the plane there. Now what I need to do now is draw a line vertically down and a perpendicular line. So draw a perpendicular line and a line down. And then what I need to do now is join these two where they meet to make a right angled triangle. So if I do that, if I can go there like that, have my right angle triangle there, and then this one here needs to be parallel to the plane. Now we can use the triangle law for forces. We'll see that as this one is pointing vertically down, that's going to be equal to the weight of the force of this block due to gravity, which will be 0.3 times g. So this is 0.3 g. Now the angle here is alpha, which will correspond to this. So I can show you why that is in another video if you like, but that will always be the same as alpha. So now we need to work out what alpha is. So we're given that alpha is, tangent of it is 3/4. So just draw a little right angled triangle and use Pythagoras' theorem. So call that side alpha. Tangent is opposite over adjacent. So opposite over adjacent, opposite adjacent. Then we calculate the hypotenuse, which if you do 4 squared plus 3 squared is 25. Square root of that gives us 5. So we know the hypotenuse is 5 in terms of this here. But what we're interested in more than that is to work out what our sine and our cosine is, because that's what we're going to need to work out this force and this force. So first of all, let's work out the force going along the plane here. So this weight will be pushing against the tension, so we're going this way. So that's going to create a negative value for this force here. So how are we going to calculate that force R1? Well, it's going to be opposite the side alpha, so we need to use sine. So let's look at R1. So we've got sine of alpha equals opposite over hypotenuse. So that's R1 over 0.3 g. Okay, so now what is that force? We just need to multiply 0.3 g by sine alpha. And what is sine of alpha? 3 over 5. So 3/5 times 0.3 g equals R1. So that's our force there. So if you do 0.3 times 3 is 0.9. 0.9 g over 5, that'll be our force. And remember, it's going in this direction. So we've got minus 0.9 g over 5. And now because we've got coefficient of friction, we need to consider the normal force. So that's this force here. That will be our normal force. So what is that? So as that's also going to be going against our friction, what we need to do, we need to work out what that force is here. So if we resolve for force 2, so resolving at 2. So then what we need is cosine. So cosine of alpha equals adjacent over hypotenuse. So it's R2 over the hypotenuse, which is 0.3 g. Now the coefficient of friction will be acting on that, so we need to multiply all of this by mu. Okay, so now cosine of alpha. What's cosine of alpha? Well, we've got 4 and 5, adjacent over hypotenuse. So we've got 4 mu over 5 equals R2 over 0.3 g. So then multiply both sides by 0.3 g and you get R2 on its own, and it'll be going against our normal force. So we've got 0.3 times 4, which is 1.2 g. So minus 1.2 g over 5. And that's all multiplied by mu, which we can substitute in for a half in a moment. And then what else have we got on there? Is that all of our forces? Well, we've got our tension, which we've not included yet. So tension is going in the right direction, so we can add T. And then we need mass times acceleration just to finish that off, which is 0.3 times 1.4. Okay, so this one, we need to just tidy this one up a little bit. Let's just keep these calculations separate as well. So 0.9 g over 5. So what could that be simplified down to? That could be 18 over 100 times by 20 times that by 20. Yeah, minus 18 over 100. Let's just leave it like that for now. And that's g. Minus, well again we've got something over 5. Let's make that over 100 as well. So then minus times that by 20. So we got over 100. And then times that by 20, we get 24. So we've got 24g, this time times by mu, which is a half. And then plus t, and set that equal to 0.3 times 1.4, or 3 14s are 42, so that's going to be 0.42. Okay, again, let's just simplify this up a little bit more. So now we can do both of these over 50. So if I times that by a half, I'll get over 200, but then divide by 4. So minus 9g over 50 minus, so divide that by 4, I'm going to get 6g, and that's going to be over 50, plus t equals 0.42. Okay, so now what I can do is, let's plug all of this into a simultaneous equation and see if we can solve for our m. Okay, let's clear this off the board. Okay, so now we've got this equation and we've got this equation here. This one's got the two m's unknown and this one has everything, but we could just isolate that into t. But let's put them together into one set of simultaneous equations. So I've got mg minus t equals 1.4 m. And then here I've got minus 9g over 50 minus 6g over 50. Well, that could be minus 15g over 50, which if I just write that out here, minus 15 over 50, if I divide through by 5, I'll get minus 3 over 10. So I'm going to write that as minus 3g over 10. So minus 3g over 10. So that's that. So, and then add t. And then set that to 0.42. Okay, so now let's eliminate t and let's see if we can solve for m. So by that we need to add. So if I add this and add this, I've got 1.4 m plus 0.42. And then add that, they disappear. Then I've got mg minus 3g over 10. So as I've got a decimal here, I'm going to turn this one into a decimal. So minus 0.3g. Okay, get the m's on one side. Let's have a go at that. So I've got mg equals 1.4 m. So if I bring this over this side, so I've got mg minus 1.4 m. Then I've got 0.42 plus 0.3 g. Now let's factor out the m. So mg minus 1.4, that looks good to me. And then I've got that there, which is 0.42 plus 0.3 g. Okay, so now I'm going to put all my values of g in there. Well, first of all, divide both sides by this in the brackets to get m on its own. So then m equals 0.42 plus 0.3 times 9.81. So that's that. And then g minus 9.4. So that's 9.81 minus 1.4. Well, that becomes 8.41. Okay, so then I've got 0.3 times 9.81. So that's 3 times 9.81 will give me 29.43. But I've got another decimal place, it'll be 2.943. And then add 0.42. So that would then give me m equals 353 divided by 8.41. Plug that in your calculator, you get approximately 0.4. So the mass of block Q is approximately 4/10 of a kilogram, or 0.4. And that would be our answer to this question. Okay.